طيب بسم الله الرحمن الرحيم. So we talked about 2.5G. We talked about the GPRS standards, and we said that GPRS standard is the start of offering packet switched services because GSM originally supports only circuit switching. So doing that, GPRS suggests a new architecture which can be integrated with the GSM. So we'll talk about, and we also discussed the the concept of quality of service classes that GPRS supports, because with packet switching, there's always the issue of quality of service, because circuit switching natively provides quality of service, but packet switching services, they don't necessarily provide quality of service natively, because the behavior, since the packets are sent with different behavior in terms of routings, there is no virtual circuit established, so the packets may encounter different behavior in terms of delay, dropping probability, and so on and so forth. So quality of service is not supported natively for packet switching services. Therefore, GPRS supported quality of service classes, and we talked about this. And we classified that in terms of reliability classes and delay classes, as well as the hardware classes. And we discussed the fact that devices in terms of hardware might support only 4 slots or 2 slots and so on, whether in the uplink or downlink. So we talked about the architecture, and we tried to sort of match and correlate this with the architecture of GSM. So the architecture here combines the packet switching services and interfaces together with the MSC and the old architecture components. And there is sort of integration between the two types of services, whether circuit switching or packet switching. So with the introduction of packet switching services that comes with the GPRS, they had to define new interfaces like this GB interface, which corresponds to the ABIS interface, and this GN interface, which corresponds to the A interface, and so on. So this one, for example, corresponds to the MSC. So this one is the serving GPRS support node, which provides similar functionality to MSC, but in the packet switching side. And then the GPRS gateway support node, which is also used to interface the GPRS network to other types of network, whether it's like PSTN or something like this. So the reflection of this on the layered stack looks like this. So again, there are new interfaces that have to be defined from scratch in the standard. And we talked about this layered stack before when we talked about GSM. So for the mobile station, some protocols have been added with the support of GPRS. So for example, there is between the base station subsystem and the core network, or the SGSN, there is frame relay. So of course, when we talk about this, is of course network access layer, and starting from this is sort of the network layer, and then this is the transport layer, and so on, right? So so for the network access layer here, we support a new protocol called frame relay, and the frame relay was actually a very common protocol at that time. So on top of this, or in the network layer level, we define what we call BSS GPRS protocol. The GPRS protocol is the one that provides the quality of service from the routing layer level. Okay, so this is the one that cares about whether you want a traffic class number 1 or 2 and so on. And then it supports the reliability level that you want based on the traffic class. In the transport level, there is also what we call subnetwork data convergence protocol. This subnetwork data convergence protocol is in the transport level, right? And this subnetwork data convergence protocol tries to provide like consistent behavior from the transport level, regardless of whatever channel state the mobile station might have. So regardless of whether the mobile station has bad channel or good channel or something like this. So this type of protocols tries to provide consistent behavior in terms of providing flow control and error control from the transport level end to end, such that it provides the same behavior regardless of the channel state of the mobile station. There is also the GPRS tunneling protocol, which is also in the transport layer, but this time it's between the MSC or the support node and the gateway. And this tunneling protocol provides like some switching between UDP and TCP. So this one controls whether you use TCP or UDP to communicate with the core network, depending on whether you need reliability or not. We talked about some traffic classes that doesn't need any kind of reliability. So in that case, you use UDP. Or if you need some kind of reliability, you use TCP. And then the GPRS tunneling protocol sort of switches between these two protocols. So this is pretty much the layer stack for GPRS. Now, when it comes to starting back from 3G, we finished 2.5G. Starting in 3G, there was a new entity that was formed as part of the International Mobile Telecommunication, or what we call IMT 2000. This is part of 3GPP. 3GPP is a standard group that started to take over the standardization for cellular standards, starting from 3G. Okay. Before it was the HC or other organizations, but then 3GPP started to take over the standards starting from 3G. So they came up with what we call IMT 2000 document, which is a requirement specification for how they want 3G to be. Okay, so that document includes all the requirement specification in terms of data rates and mobility handover, all types of requirements in every layer. As a result of the IMT 2000, there were two proposals for 3G that came from different organizations. This is the Universal Wireless Communication 136. You don't have to memorize all of this, but this is from the US side. So there was a proposal from the US and there was a proposal from HC or the European side. So there was one proposal from Europe and one proposal from the US. This is the one that's more common, of course, and that's the one that became dominant after this. It's called Universal Mobile Telecommunication System. Later on, they named it Universal Terrestrial Radio Access, or UTRA. Okay, so this is UMTS is actually UTRA, and that was the proposal from Europe side that sort of tries to meet the requirement specification for IMT 2000. Okay, so IMT 2000 is the requirements document. Based on that, some organizations, they have proposed like some standard documents, and later on UMTS was adopted as the universal 3G standards, and that was the proposal presented from the European side. UTRA is actually a set of releases. As we will see in a minute, the 3G is not actually like one standard document and that's it. There was releases. So it started with the release 99 and then release 00 and then release 4, 5 and so on. So we'll see that. So the first release started to talk about some enhancement to the GPRS architecture or the GPRS standard. So UTRA here defines what we call the edge or the enhanced data rates for GSM evolution. And this edge is actually مجرد يعني it's an enhancement to GPRS to try to provide, if you remember, we talked about in GPRS, we talked about data rates in the range of maybe 50 kilobits per second to 80 kilobits per second, depending on how many slots the mobile station can use concurrently, whether in uplink or downlink. So Edge actually tried to enhance this to 384 kilobits per second. It was like a huge upgrade. And what they have proposed is to use a higher constellation using QAM modulation. So they proposed to use like 8 QAM or something like this to try to increase the data rates. And they have used a data rate of up to 384 kilobits per second. And of course, this is not fixed, yani. You can achieve higher or lower depending on whether we are talking about rural area or suburban or urban area, depending on the range, depending on the antenna configuration for the base station and other things. In any case, of course, the data rates were higher, and the only added thing was like the modulation scheme or the physical layer techniques. They also talked about Camel or the customized application for mobile and a virtual home environment. And these are application level services that sort of did not exist before in 2G. In 2G, if you remember, we talked about very, very basic application level services like fax and things like, which is like very, very primitive. So these parts of the standard, they tried to talk about some prepaid services and some call forwarding and other types of services just from the application level. These two, they do not focus on any kind of physical layer techniques. So these talk about only enriching the application level services. So more mobile services on top of the cellular network. So, for example, the virtual home environment, this virtual home is not like, it doesn't talk about house. Virtual home environment here focuses on providing consistent and personalized behavior for the user regardless of whether the user is roaming or not. For example, I have, for example, when I connect to Ooredoo, I have core forwarding service. I have some personalized services for me, right? So the assumption is that when you roam to another network, do you have to maintain these personalized services or not? Do we have to negotiate between the home network and the visited network to maintain your services or not? Okay, so in 2G there was nothing like this. This concept was not there. So the fact that you visit another network, it doesn't mean that you maintain your services in any way. Okay, so a virtual home network here tried to talk about this, providing conversion and consistent personalized behavior for the user regardless of his location, whether he's actually in the home network or roaming in any other network. So maintaining that service across the different networks is part of the virtual home environment. Okay, so so 3GPP, they started to streamline the releases and the standard. Of course, definitely you don't have to memorize all of this. You just need to understand that standards, they come in releases. Okay, the release that we will focus on as part of this is the R99, which tries to address or tries to fulfill the requirements from the IMT 2000. IMT 2000 is the requirements documents with all the detailed specification, and this release is the one that tries to target fulfilling these requirements. And even then, the 3GPP, they started to work on this, and we will detail what's in this release. And then they actually realized that releasing the standard to completely comply with IMT 2000, INT 2000 came from the fact that 2000 here came from the fact that it should be released in year 2000. Okay, and also 2000 here actually indicated 2000 megahertz, which is the average carrier frequency that should be used as part of the UMTS. So 2000 here has two indications يعني. ماشي. It just happens to coincide at the same time. المهم يعني إن هو they realize that it's impossible to actually come up with the release by the year 2000, and then they have divided the release اللي هي release 00. They divided that into 4 and 5. So these two releases they focus on by the finalized standards that meets 100% of the requirements of IMT 2000, and that's what we call by يعني together these two releases we call them by 3G standards. ماشي. So by release 5 the 3G standards تقدر تقول إنهم يعني they are done, they are finished.
There was, I think, a problem in 2000 on the internet was about the zeros or something.
Yeah.
They also face the same problem when they are coming with the...
I don't know. I don't know. Everybody was talking about year 2000, and يعني, there was a big issue, and then it ended up being no issue. يعني, it was a big anyway. It was a big issue. يعني. I'm not sure if it affected the standard or not, but I don't think they have found it impossible to finish the standard because of this. I don't think so. I think there were other issues. Usually some issues related to the fact that each vendor, they try to influence the standard, and they actually, these standard meetings, they end up being like a big fight, and each vendor, they try to force their technique and their technology to be part of the standard, and then they get resistance. And so there is يعني, some fight that sometimes happens in these types of meetings. And sometimes that delays the release of the standards for some time. As we will see, it did not happen until release 5 that really there was a convergence of all IP network. Because if you see the architecture for GPRS, it still maintains circuit switching and packet switching. So it's not pure IP. It's not pure IP. So we could not get rid of circuit switching. Although we can support voice services over IP, but we could not get rid of the circuit switching architecture until release 5 that sort of converged everything into all IP core network. So even release 99 did not do that. We'll talk about the architecture. In any case, so these are يعني the releases, and they freeze some of these releases to be like 3G or 4G or something. So 4G, for example, I think it happened somewhere around release 10 and release 11. That's when we started to talk about 4G in particular, okay? And there was actually 3.9G. We'll talk about this. يعني أقصد here, it's not binary 3, 4, and that's it. So we talked about 2.5G. Right, and when do we call the standard to be like 3G or 4G? That's when the release sort of meets 100% of the requirements of the specification that was put forward, right, by the ITU. Okay, so there was or by the IMT. Entity or the IMT organization. So the IMT, they put the requirements, and then once you meet 100% of these requirements, then we can call it 3G or 4G. So for example, 4G corresponds to what we call IMT advanced. So first they call it IMT 2000 with the hope that it would be released in 2000, and then they realized that it's not good to name the specification after the year in particular. So for 4G, they called it IMT Advanced. So the first standard for that tries to meet the IMT Advanced was the LTE. So LTE was the proposal that tries to meet the IMT Advanced, but LTE did not actually again, did not comply with the IMT Advanced 100%. So they called LTE actually 3.5G. And then there was the LTE Advanced, which is the one that currently we use as 4G, and 4G until today it exists. Anyway, so these are the releases. يعني هو details كتير يعني, but these are the releases. Each of these releases, they go through these stages. We don't have to really know the details of these stages. It's like any other, you know, project. So it starts with like some feasibility study, some requirements analysis, and then some detailed design, and then some experimental testing and verification, and so on. So these are the stages. So each of these releases, they go through these stages. So we don't have to, يعني, it's like we just need to take things high level. يعني. So this is the simplified architecture for UTRA or UMTS. So UTRA here talks about the fact that you have the UE, or the user equipment, which corresponds to a mobile station. ماشي? So this UE is the user equipment. Just a change of terminology. ماشي? So this UU is the UM interface, which corresponds again to the UM interface. For UTRAN is the radio access network, which corresponds to both the base station and the base station controller. So this is the UTRAN, or the access network. And then the core network corresponds to everything else, including بقى MSC and the home location register and all of this. So this is the core network. So I'm just trying to relate things together so that you can يعني it becomes يعني easier to understand. So with this matching in mind, you can sort of guess the functionality for the UE. So the UE is the user equipment, which is responsible for, again, all the radio functionality, in addition to all the application level services. And of course, there is the SIM card, which maintains the user identity and all the encryption stuff and so on. The UTRAN, of course, is the access network, which again subdivided into the base station and the base station controller. Here they call it something else. We'll see. And again, this is again responsible. This is the يعني these two parts are the infrastructure part, which belongs to the service provider, and this UE, of course, belongs to the user. So the UTRAN part again is the access network part, or radio access network, or universal terrestrial radio access network, to be يعني precise. And this is the one that's responsible for handling all the radio access resource allocation and so on, as well as all the cell level mobility. يعني when you move from one cell to another, such that these two cells, they belong to the same base station controller, then the UTRAN is the one that controls that type of mobility. But if you move from one radio access network to another radio access network, which belong to different BSC, then that's what we call a enter BSC, which means that you have to trigger, or you have to engage the core network. So the MSC has to control the mobility in that case. Okay? So this is the enter system handover, as well as, of course, if you do roaming, or if you move to another network, then of course the core network has to be naturally engaged. ماشي كده؟ طبعا we'll dig into this, and we'll start to zoom in and take a look at the. طبعا ال IU interface, again, this IU interface corresponds to the A interface in GSM. Again, hopefully when you relate things together, it becomes easier to know the functionality and to get more يعني detailed. This simplified architecture is subdivided into what we call domains. This concept of domains was new in UMTS. Again, there is the user equipment domain, and there is the infrastructure domain. User equipment domain is one per user, of course, whereas the infrastructure domain is one for the service provider. So the user equipment domain, similar طبعا, similar to GSM برضو. It has the universal SIM, okay, domain, which again is the same card that that gets inserted into the mobile phone, and then the mobile phone بقى uses the it has two functionalities, the radio functionality to interact with the base station, as well as the application level services or the interface that provides all the services. From the infrastructure domain level, you have the access network domain, which includes, of course, again the base station, or we'll call it هنا radio network controller. ماشي يعني it's the same يعني same thing. And of course we have the IO interface which corresponds to the A interface. And then بقى هنا اللي هو الجزء بقى بتاع الكور network, we have what we call serving network domain, and we have home network domain, and we have transient network domain. So the difference is actually slight. So هنا بقى يعني you're supposed to support roaming. فأنت as a subscriber, you always have a home network domain, which is the main network that maintains your identity and services, right? So the home location register that stores your identity and everything is in your home location or home network domain. So I'm a subscriber of Ooredoo, then Ooredoo's network is my home network domain, okay? And there is the service network domain. Service network domain is the one that I'm currently utilizing the service from. I could be in Bahrain, I could be here, I could be here. I could be roaming from Ooredoo to Vodafone or something like this. So there is a network domain which currently serving me and providing me the services. طبعا, of course, with some agreement and interaction to the home network domain. Sometimes the visited or the serving network domain needs to contact the home network domain to get your identity and stuff. So there is some kind of interaction that happens between the two domains. And sometimes when you roam from the home network domain to the serving network domain, sometimes كمان you have to pass through some transient network domain. Transient network domain is a temporary network domain that sort of provides the interaction or the interface between the home network and your visited or your serving network. Okay, so for example, between Ooredoo and Kaza, I may have to pass through ISDN network or another type of network. So this is the transit network. But this doesn't mean that this network will provide any services for you. The service is provided by the serving network domain, but I have to go through that as part of the roaming functionality. So this is these are what we have described in detail. So we have the USIM, which provides the function for encryption and authentication of the users, located on the SIM card, which is inserted in the mobile device. And then there is the mobile equipment domain, which is the main phone, the hardware of the phone, which provides the functions for radio, as well as the user interface for establishing and maintaining end-to-end connections. And then there is the access network domain, which provides by all the access network dependent functions, including by radio, resource allocation, and all of this. And there is the core network domain, which accesses the network independent functions, including by everything related to billing, provisioning the different types of services, whether you have access to a particular service or not, and so on. طيب, in terms of طبعا one thing we discussed before is that starting from release 99 and all the 3G standards, they utilize what we call a CDMA. طبعا we're not talking here about FDMA anymore. Okay, so here we're talking about CDMA. So we talked about CDMA as a concept, and we talked about the fact that we use orthogonal codes, and these orthogonal codes, they get multiplied by the signal to spread the signal in the frequency domain, such that these codes are orthogonal to each other, right? To provide some isolation between the user signals or the user data, right? So we talked about this before. Some of the issues of the CDMA, we talked about some major issues, including the near-far effect, of course, and that can be sort of resolved by using some adaptive power transport, or sorry, transmission power, adaptive transmission power, just to resolve the near-far effect. We talked about this before. Another basic problem in all CDMA networks is the fact that you need to synchronize the chips or the codes. The generation of these codes have to be synchronized between the different users, right? If you don't have synchronization, then the orthogonality will be affected, right? And that's one of the limitations that they looked at in 3GPP, in UMTS. Of course, to synchronize the generation of these orthogonal codes is a very complex process, because as we said, when we talk about distributed clocks, there is always clock drift, and so generating these codes such that they are completely synchronized is kind of tricky. So they provide what we call by quasi-orthogonal codes. Okay, what happens here is that this quasi-orthogonality, it sort of waives the restriction that it has to be completely synchronized. So the codes, they are generated, and we'll see how they are generated. But then they have to be scrambled using what we call scrambling codes. These scrambling codes with the spreading codes, together, they first of all, they waive the restriction that it has to be completely synchronized, right? And they make the codes sort of quasi-orthogonal. So quasi-orthogonal, it does not have to meet 100% the fact that the product of these codes equals 0, but they create the situation of what we call low cross correlation. ماشي؟ يعني we don't have to know the details, بس يعني quasi orthogonal codes, they don't have to be completely orthogonal. They have to be, or they try to maintain the quasi orthogonality. Quasi orthogonality, if you do the product of two codes, ماشي? The product of the two codes, it's not 0. But if you do cross correlation, then the result will be very low, يعني almost 0, right? So in order to make these codes quasi-orthogonal and not completely orthogonal, they use the concept of scrambling codes. So after you use the spreading code on the individual user data, use the spreading codes. اللي هي the spreading codes, this is using بقى CDMA codes. This is what we talked about before. But after doing this, then they do what we call a scrambling code. This scrambling code usually is unique per user, and these scrambling codes, they make the user data, again, not a completely orthogonal, but what we call a quasi-orthogonal. And that does not require synchronization. It does not require complete synchronization. ماشي? So the benefit of the quasi-orthogonal codes is that it does not require a complete synchronization between the users. And it does not require the fact that the product of two codes is 0. The product is not 0, but the cross correlation is very small. ماشي؟ واضح كده؟ So that's the concept. So so this way they get around this restriction of having to have 100% synchronization. So here, per sender, you have scrambling code, and this scrambling code is unique per user, and it makes the traffic of the two users quasi-orthogonal and not completely orthogonal. In addition to this,
what about the spreading code?
Yes, the spreading code بقى, spreading code اللي هو, this is the orthogonal codes, yes. This is the orthogonal code. One thing here is that these orthogonal codes, they get generated using fixed fixed rate ماشي اللي هو 3.85 mega chip per second. So all UTMS all UMTS standards they utilize fixed chipping rate اللي هو ال spreading code rate is fixed. The spreading code rate is fixed. Scrambling does not affect the rate. Scrambling is just that you get some bits and then you scramble it بس. You do some permutation similar to اللي احنا بنعمله في السكيورتي مثلا, right? But the scrambling is done in a way that's unique for each user بس. ماشي? So scrambling does not affect the data rate. Okay? طيب. The chipping rate is fixed. Okay? So this chipping rate gets multiplied by the user traffic, which causes the spreading to happen, and then we do the scrambling, and then we send it over over the channel. So this the spreading process uses what we call by a variable spreading codes or variable code spreading. So you can use a spreading code different for each. For example, here, these spreading codes, they get generated using like a binary tree. Okay? So if you generate the codes using this binary tree, if you multiply any of these two codes, assuming that they are synchronized, they fulfill the orthogonality condition completely. Right? So so this is 1. You see this 1, 1, 1, minus 1. And then you replicate. You get this, and you multiply it. You multiply it, and then here it's minus 1. So you get this and multiply it by minus 1. Okay? So 1, 1, 1, minus 1. So as long as you generate these codes using this binary tree, the codes, regardless of their length, will be orthogonal. Okay? So why do we have to generate it using this binary tree? To have what we call variable spreading factor. Variable spreading factor here talks about the fact that if we use spreading factor 2, this means that each bit from the user data will be spread into 2 bits. واضح كده? So the spreading factor is 2, which means that each 2 bit from the user will be spread into 2. If you use this code, then 1 becomes 1, 1, and 0 becomes minus 1, minus 1. As simple as that. واضح كده? And then if you use this one, then 1 becomes 1 and minus 1, and 0 becomes a minus 1 and 1. So each bit will be spread into 2. ماشي? If you use spreading factor 4, this means that each bit will be spread into 4 bits, and so on. 8, and then 16, and so on. Okay? Which technically means, since the chipping rate is fixed, lower 3.84, ماشي? If I want to know the data rate, right? Then all I need to do is just to divide the chipping rate divided by the spreading factor. This is the user data rate. Okay? So if each bit becomes 2, this means that I will divide the rate of the user by 2, which means that the actual data rate that the user will achieve is actually 3.84 times 8 to the power 6 divided by 2. Okay? If the spreading factor is 4, then I divide by, and so on.
And the spreading factor, the user can choose any of the 8. Or 8
no, you can actually, you can use different spreading factor for each user. You can use different spreading factor for each user. This is what we call it's called orthogonal variable spreading codes. Orthogonal variable spreading codes. ماشي? So, for example, one user can use this code, and another user can use this code, and another user can use this code. So you can technically have, but the rule is ما ينفعش one user يستخدم اخد ده وanother user يستخدم ده. No, you cannot do that. Of course, because these are not orthogonal codes in that case. So once you take this, all the terminal nodes that belong to this cannot be used by other users. خلاص. Okay? So this means that the code for this user is 1-1. That's it. ماشي? Other users can use the other codes from other branches, but not this one. خلاص. Because if they use the code from another terminal node under the same code, then the orthogonality will not be maintained طبعا. So these codes are not orthogonal. واضحة النقطة دي؟ اتفضلي.
Why is there like higher spreading factors when that would affect the data rate?
That's a good question. That's a good question. Why do we have higher مثلا spreading factor for each user? Well, the idea here is that the more you spread the signal, the more it becomes resistance to noise. Right? So if you want to have some user data more resistive to noise, then, but spreading means a less data rate for the user. So it becomes a trade-off that. ماشي؟
If we spread more, we'll have more users.
لا ايه يعني ايه more users؟
Because
لا هو the chipping rate is fixed. Remember, the chipping rate is fixed. When you spread more, when you spread the user data using a more spreading or higher spreading factor, this means that this particular user will have less data rate, but more reliability or more resistance to noise.
yes, but if the
right.
SF is 2, for example, we can't have more than two users.
لا بس remember all the mobile stations, they can use all these codes. All of them can use all these codes. Any one of these codes يعني. So the mobile station, of course, can select any of these code in the tree, and it's controlled now by the base station which code is assigned to which mobile station. So this is the resource allocation part. So the resource allocation part here is different from FDMA. Resource allocation here will assign the code and the spreading factor for each user. And by doing that, I may have to change the achievable data rate for a user, but this user with low rate will be more resistive to noise based على controlling the spreading factor. Of course, in addition to of course, adapting the power, the transmission power for the near-far effect and all of this. So this is done by the base station. ماشي؟ طيب, in terms of architecture, so this is what we call بقى radio network subsystem. So the radio network subsystem corresponds to the base station subsystem. يعني is the same. هنا we call it radio network subsystem. And again, this node B corresponds to the BTS, and this RNC corresponds to the BSC. يعني similar يعني, بس طبعا هنا we have ال IO interface, and هنا طبعا ال U-tran they can work, or the node B can use whether FDD or TDD. هتقول لي الله طب ما احنا مش كنا لسه بنقول CDMA ماشي؟ FDD and TDD is not a modulation scheme. It's not يعني لا هو this is a duplexing. This is a duplexing for duplexing. So I may have different frequency for uplink and downlink, or I may have different TDD or يعني time domain or time frames. ماشي? So this is for duplexing and not for time slot allocation. واضح كده؟ طيب. So again, the architecture you can relate it to each other. So نتكلم بقى على الايه main differences. طبعا again similar to GPRS هتلاقي هنا في similarities كبيرة قوي بال GPRS. هنلاقي ال MSC still there. So MSC is circuit switch based. هنلاقي برضو ال gateway MSC, وهنلاقي برضو ال SGSM for GPRS. So both are maintained. What is the difference here? The difference is this part. So the radio network subsystem, now I have a different radio network subsystem, ماشي, which UMTS defines. This radio network subsystem بقى is the one that uses CDMA and FDD and TDD and so on. This is what the node B and so on. In addition to, again, the legacy system, which again still uses BTS and BSC. So corresponding to the ABS interface, we have the IUB. And then the IU here is divided into two parts. This is the IU circuit switched part, and there is the IU packet switched part. ماشي? Both of these types of radio network subsystems, they can utilize whether circuit switching or packet switching. Both of them. So the main difference is that this one uses CDMA, and this one uses a FDMA, TDMA. واضح ماشي? So this is the main difference in this architecture. Other than this, again, it's similar to GPRS and GSM. So the core network, and that's the interface اللي هو IU, are separated into two logical things. There is the IU circuit switch, which provides all the circuit switching, اللي هو IU CS, and there is the IU packet switching, which provides all the GPRS or all the packet switching services. ماشي? So release 9 uses the DSM GPRS. So again, there was no conversions until release 5 that really it becomes completely all IP. The core network becomes all IP, and there is no mention for circuit switching anymore. ماشي? It becomes all packet switching and all IP. So that was introduced in release 5. طيب. Okay. طبعا هنا برضو for handover and mobility, also UMTS provides new techniques for handover. What we talked about in GSM was the fact that we said that during handover we have the time or chronological signaling signals that achieves the handover. And we said that at some point we have allocated resources in two BTSs, right? But always the node uses the old BTS, right? Until we establish the end-to-end link, and then it moves the service completely to the new BTS. So that was the handover provided by GSM. UMTS بقى provides what we call بقى إيه? Macro diversity. And what that means is, طبعا, due to the fact that we started to have more dense network, which means that the cells, especially in rural areas, the distances between the cells becomes smaller and smaller to have more user capacity. So the UE, when it moves from the range of one node B to another, or from one antenna to another, right? Here it becomes in the middle of multiple node Bs or multiple antennas, right? So the handover in GSM, what it does is that it allocates resources in the new BTS, and then it moves the service from here to here. So this is what we call hard handover. Hard handover means that the UE will have the service from one node B at a time, right? So it continues to use the service from the old BTS or the old node B until it moves to completely and establishes the connection end-to-end through the new node B, and then it moves the service from the old to the new. This is a hard handover. UMTS came with the concept of soft handover, and what that means is, since we have allocated resources here and here, right? Because you said that, right? So at some point we have the resources here and here. So the UE, in that case, for a period of time, it will actually multicast the traffic to 2 or 3 node Bs, right? So it multicasts the traffic. And this traffic will get mixed at the RNC. And then the RNC will, by combining the traffic, it will use the macro diversity to increase the reliability of the traffic. So the traffic, it receives multiple streams from the same UE at the RNC, and then it mixes the traffic together. So it mixes all the signals together, and in that case, it maintains more reliability. Okay, unlike GSM. GSM doesn't do that. So it allocates the resources on both BTSs, but it uses one BTS at one point of time. Here we can multicast the traffic on multiple BTSs, 2 or 3 or something. You see? So, and that happens in uplink and downlink. So in uplink, we have simultaneous reception of UE data at several nodes. So in the uplink, so all these 3 nodes, they will receive the same signal that comes from the user. And then these signals will get mixed and aggregated here to increase the reliability of the end-to-end transmission. Okay? In the downlink, again, the simultaneous transmission of the data via different cells and via spreading codes, they get mixed at the UE. So you get 3 signals coming from these 3 nodes to the UE. And the UE mixes all of them, and this way it can use this mixing or this aggregation to increase the resistance against noise by using the concept of macro diversity. ماشي? So this is the concept of multicasting or mixing the traffic from multiple nodes, whether to or from the UE. In that case, we have 2 types of RNSs. We have what we call the serving RNS. This serving RNS is the one that the UE is connected to, and this drift RNS is the one that the UE is moving towards, right? So the serving RNS, right, whether in the uplink or downlink, it will receive or send the traffic to the UE, right? As well as in the drift RNS, it will do the same. But then the serving RNS is the one that mixes the traffic together. And then it sends it to the core network. So all the way until the IUB interface, right, is duplicate. You have duplicate traffic going from UE all the way to E node B and then to the RNC, right? And then the serving RNC will mix the traffic from the drift RNC اللي هي this is بقى the node that the UE is moving towards, right? And then it mixes the 2 traffic at the serving RNC, and then it sends it to the core network. So this way we can increase the reliability and the resistance to noise and so on and so forth. Until the handover is finalized. Once the handover is finalized, then the drift RNC will become the serving RNC. واضحة دي؟ ماشي؟ The drift RNC will become the new serving RNC. And then there is another node that will act as the drift RNC and so on. So by doing the handover, we have this concept of multicast or mixing traffic. تفضل يا
RNS same as RNC.
يعني RNS هو ال RNS اللي هو radio network subsystem that includes the node B and the radio network controller. قلنا النود B اللي هو corresponds to BTS وال RNC اللي هو corresponds to BSC. Together اللي احنا we used to call it BSS, now we call it RNS. يعني خد بالك بقى من من ال different terminology يعني. تمام كده؟ So this is the concept of macro diversity. This is the concept of macro diversity. إنه احنا we can utilize the duplicate resources allocated on both nodes to also increase the reliability and the resistance to noise. ماشي؟ Using the concept of multicast. طبعا again using the same concepts that we talked about. Now we have 5 types of handovers بقى, not 4 types. Now we used to talk about 4 types in GSM. Now we have a 5th type, which is بقى moving from the packet switching side to the circuit switching side, or from node B to a BTS, from the RNC or from RNS to BSS. ماشي? Because now we can hand over between 2 different radio access networks. One utilizes packet switching and the other one utilizes circuit switching. So that's a new added type of handover. We talked about قلنا intra node B handover, which means that we move from one antenna to another or from one channel to another, right? So this is within the same cell. And then we have a handover. We move from one node B to another. But both node Bs, they are connected to the same RNC, اللي هو BSS, اللي هو بالظبط, connected to the same BSS or BSC يعني, base station controller, صح؟ ماشي? And if we move from one node B to another such that both of them, they correspond to different BSSs or different INSs, RNSs, then this is what we call enter RNS handover. ماشي? And there is different, if we move from one location area to another, ماشي? One location area is maintained by one 3G MSC and the other is maintained by another 3G MSC, then that's a different type of handover. And then there is the handover, the 5th handover, اللي هو between بقى ال 3G MSC and the 2G MSC, moving from 3G to 2G. طبعا mobile stations that support 3G, they are backward compatible. So that's why actually when you roam from one network to another, sometimes you see the service has been dropped down. I'm not sure if you live these days. We used to have on the phone 3G and now it's 2G. طبعا now يعني either 5G or 4G.
For the you get full تغطية يعني full you get it to 2G so that you can call and
Right.
on the internet.
Right. So if you move from 3G to 2G, that's the type of handover that happens. ماشي كده؟ طيب, so this is the UMTS and the 3G standards. Very quickly and very high level بقى. We talk about بقى some UMTS enhancements. So this is what we call بقى 3.5G, similar to 2.5G. So these are 3.5G. So at a very high level, so there is the high-speed data or downlink packet access. ماشي? From the name, downlink packet access. So it tries to increase the data rates in the downlink. So you will see the uplink is still the same, but the downlink has increased through the use of 16 QAM. ماشي? So through the use of MIMO and 16 QAM, they were able to increase the downlink at least to rates of 3.6 and 7.2 megabits per second. But only in the downlink, but the uplink is still the same. And another enhancement that focused on only the uplink. And here, the packet access here, or HSPA, or high-speed packet access plus, which tries to have increase in the downlink and the uplink, both. So in the downlink and the uplink, they increased the speed in both sides. ماشي? So these are all 3.5G standards. Okay, these were very common and very famous at some point of time before the release of LTE. So for once the LTE has been released, LTE itself was initiated in 2004. طبعا, of course, the deployments for LTE did not happen until maybe 2009 or 2010. ماشي? LTE itself is called 3.9G and not 4G. 3.9G because, again, the IMT, they released the requirement specification for 4G, which is called IMT Advanced. The IMT Advanced talks about the specification for 4G. The first proposal or LTE proposal did not comply 100% with the IMT Advanced. So they came up with the release, I think it was release 10 or something, for LTE. LTE بقى uses بقى what technology or what يعني physical layer technology اللي هو الايه؟ اتكلمنا عن الموضوع ده قبل كده اللي هو ايه؟ OFDMA. So it doesn't use بقى CDMA, it uses OFDMA. ماشي؟ And LTE, as I said, does not comply 100% with IMT Advanced. And it supports downlink speeds of up to about 100 megabits per second and uplink speed of 50 megabits per second. Again, you don't have to memorize these things, but of course, naturally, there was huge amount of upgrade. And of course, it went through some stages. As we said, LTE is not 4G. Sometimes they call it 3.9G. It does not fulfill the requirements of IMT 2000. So this is بقى the one that sort of converges. As we can see here, we don't see بقى MSC anymore. We don't see بقى MSC خالص هنا. حتى GPRS becomes like a visited network or another network. Here we converge, and instead of node B, we use eNode B or enhanced node B. Again, yeah, just to, يعني an interesting thing. Node B, why do we call it node B? يعني, why node B? يعني? What is the meaning of node B? Oh, B stands for broadband. ماشي? Node B, يعني كلمة generic خالص. They put it in the standard. Well, the book actually mentions that. They put it in the standard for a lack of a better word. And then they said, okay, so we'll change it in the standard later on. And then it was stuck, and they never changed it. They never changed that in the standard. So that tells you that these standard people, they are human beings. يعني they can do all sorts of interesting things. يعني. So this MME, right, corresponds to a, as you might guess, يعني, corresponds to a MSC أو اللي هو ال GPRS support node. Similar thing. So it's called mobility management entity. ماشي? But هو actually this MME and the serving gateway together, both of them correspond to the MSC. ماشي? They split the functionality in 4G to MME and the serving gateway. And then there is the packet gateway, which corresponds to the actual gateway that connects you to another network. But other than this, you have the, this is the, طبعا, this corresponds to the اللي هو home location register or visitor location register and all of this. And then the eNode B corresponds to the actual cell. طبعا 4G still uses بقى MIMO, uses برضو the concept of macro diversity for handover, اللي هو soft handover or hard handover. So it uses this concept. And yeah, so this is the we don't have طبعا to talk in details about this, but يعني we can relate it to the other standards. And then came back LTE Advanced. LTE Advanced.
Yeah.
LTE Advanced is the one that يعني we can call it pure 4G. So this is بقى يعني it supports بقى compatibility services, and it supports inter-networking with other radio access networks. The data rates are very high. It utilizes طبعا OFDMA, not CDMA anymore. طبعا ال bandwidth. We talked about, if you remember, we talked about 200 kilohertz bandwidth, and now we're talking about 100 megahertz bandwidth. So you can imagine the big difference. 200 kilohertz bandwidth for GSM. It allowed us to achieve bit rates of in the range of kilobits per second, and of course here. And of course, here we're talking about big, huge bandwidths. انت تخيل بقى this bandwidth is divided into OFDMA carriers or subcarriers. ال OFDMA يعني طبعا احنا we don't talk about that, but ال OFDMA the difference is that if you imagine كده مثلا in the frequency domain very very high level يعني ال OFDMA طبعا يعني we can talk for hours about this. طبعا احنا عندنا ال channels بتاعتنا عامله كده, right, and there is GAR band between them for the case of FDMA. OFDMA talks about the fact that not only I remove the GAR bands, but I do the carriers, the subcarriers like this. So the subcarriers will become like this, right? So there is overlap, but the overlap is done carefully in a way that the peak here corresponds to 0 in the next subcarrier. So it's like you are taking the subchannels and you're squeezing them. Okay? So we use here the orthogonality بقى in the frequency domain, not in the code domain. So this way, I can squeeze thousands and thousands of these subcarriers in the same frequency band that we can use. And these subcarriers بقى, طبعا of course there is overlap, which means that there is inter-symbol interference and all of this. But we deal بقى with this through some يعني techniques such that we minimize the effect of the interference using the orthogonality in the frequency domain. So that's roughly how the OFDMA works. For the analysis, for our analysis or simulation, OFDMA, they deal with it from a high level similar to FDMA. So instead of talking about subchannels, we talk about subcarriers in OFDMA. But يعني in terms of calculating بقى the achievable throughput, we use برضو اللي هو الايه الشانون equation, but on the level of one subcarrier. ماشي, so we can do subcarrier allocation and we can achieve throughput per subcarrier, similar to what we used to do for FDMA, but now on the level of subcarrier. ماشي كده؟ Any questions? Any?
So we till next week.
أعتقد